Hello everyone, welcome to new class. So today's class is about system of homogeneous equations. That is the solution of system of homogeneous equations. And in the previous classes we have discussed about the solution of non-homogeneous system of linear equations. So next is solution of system of homogeneous equations. So consider a set of equations, that is a11 x1 plus a12 x2 plus etc plus a19 xn equal to 0, a21 x1 plus a22 x2 plus etc plus a2n xn equal to 0, etc am1 x1 plus am2 x2 plus etc amn xn equal to 0. So in the non-homogeneous system of equations, we have Ax equal to B, and this is homogeneous. So this is non-homogeneous system of equations, and this is homogeneous system of equations. So here Ax is equal to 0, that is here B matrix is equal to 0. So this is homogeneous system of linear equations. Then about the solution of the system of homogeneous equations. If rank of coefficient matrix, so here R means rank of coefficient matrix, that is A, because here B is 0, so we have to only find the rank of A. So if the rank of A is equal to n, that is the number of unknowns or number of variables, then there is always a trivial solution. Trivial solution means x1 equal to x2 equal to etc xn equal to 0. Then second one is if rank of A is less than the number of variables, then there exists a non-trivial solution. For non-trivial solution, determinant of A is equal to 0. Also note that Ax equal to 0 is always consistent. That is, x equal to 0 is always a solution. And this solution is called trivial solution. And if rank of A is equal to n, then Ax equal to 0, that is this one. So Ax equal to 0 is always consistent, and we get like this, that is rank of A is equal to n, then Ax is equal to 0 has only trivial solution. That is, in general we can say x equal to 0 is trivial solution and x is not equal to 0 is called non-trivial solution. Let us do a problem. Solve the system of homogeneous equations. X plus 2y plus 3z equal to 0. 3x plus 4y plus 4z equal to 0. 7x plus 10y plus 12z equal to 0. So here first of all we have to find the matrix A, that is the coefficient matrix, that is A is equal to 1, 2, 3, then 3, 4, 4, 7, 10, 12. So this is matrix A. Now we have to find the rank of this matrix, that is by the row operations we can find the rank of A, that is we have to find the number of non-zero rows here. So first of all we can make these two elements 0, that is do the operations. R2 implies R2 minus 3 times R1, R3 implies R3 minus 7 times R1. So here we will get 1, 2, 3, then 0, then 4 minus 6, that is minus 2, then 4 minus 9, that is minus 5, then 0, 10 minus 14, that is minus 4, then 12 minus 21, minus 9. Now here we can make this element 0, that is R3 implies R3 minus 2 times R2, that is 1, 2, 3, 0 minus 2 minus 5, then 0, here 0, then minus 9 plus 10. So here we will get 1. Now this is the reduced matrix. So here we can find the rank of A. That is, here rank of A is equal to the number of non-zero rows. That is, here non-zero rows are equal to 3. And here which is equal to the number of unknowns. So number of unknowns also equal to x, y, z. That is, number of unknowns equal to 3 here. So if the rank of A is equal to the number of unknowns, then the system has trivial solution. That means here x equal to y equal to z equal to 0. That is, x is equal to 0. That is, x equal to y equal to z equal to 0. That is the trivial solution. So this is the solution of this system of equations. Let us do another example. So here the system of equations are x plus y minus 2z plus 3w equal to 0, x minus 2y plus z minus w equal to 0, 4x plus y minus 5z plus 8w equal to 0, 5x minus 7y plus 2z minus w equal to 0. So here the coefficient matrix A is equal to 1, 1, minus 2, 3, 1, minus 2, 1, minus 1, then 4, 1, minus 5, 8, 5, minus 7, 2, minus 1. Now we have to find the rank of this matrix. So for that, let us make these elements 0. That is, we can do the operations. R2 implies R2 minus R1, then R3 implies R3 minus 4 times R1, then R4 implies R4 minus 5 times R1. Then here we will get 1, 1, minus 2, 3, then 0, then here minus 2, minus 1, that is minus 3, then 1, plus 2, 3, minus 1, minus 3, minus 4, then 4, minus 4, 0, then 1, minus 4, minus 3, minus 5, plus 8, that is 3, then 8, minus 12, that is minus 4, then 0, then minus 7, minus 5, that is minus 12, then 2, plus 10, that is 12, then minus 1, minus 15, that is minus 16. Now here these two rows are equal, so here we can make one row 0, and also we can make this element is 0. That is, we can do the operations. R3 implies R3 minus R2. Then here this row will be 0. Then R4 implies R4 minus 4 times R2. Then here we will get 1, 1, minus 2, 3. Then 0, minus 3, 3, minus 4. 0, 0, 0, 0. Then here we will get 0. Then this is 0 here. 12 minus 12, 0. Then minus 16 plus 16. So this one also 0. So here two rows are 0. That is, here the number of non-zero rows equal to 2. So the rank of A is equal to 2 here, and here the number of unknowns or number of variables are x, y, z and w, that is 4. So here the rank of A is less than the number of variables. So there exists a non-trivial solution. So there is a non-trivial solution. And let us find the solution. So if rank of A is less than n, then we can find n minus r, then the solution is that much variable independent solution. That is, we have to assume value for n minus r variables. So here find n minus r, that is n is 4, 4 minus 2, rank of A is 2, that is equal to 2. So we have to assume value for two variables, that is let k1 and k2 be the two variables. So k1 and k2 be the two variables, and hence here the solution is two variable independent. So let us write this in the form, that is ax equal to b form, that is here b is 0. So here we can write x plus y minus 2z plus 3w equal to 0. Then from the second row minus 3y, then plus 3z minus 4w equal to 0. So here we have to assume k1 and k2 for two variables. So let z equal to k1 and w equal to k2. Then here we will get y equal to, so from this equation y equal to 3z minus 4w divided by 3, that is 3k1 minus 4k2 divided by 3. That is y is equal to k1 minus 4 by 3 k2. Then from the first equation we will get x equal to minus y plus 2z minus 3w. So here minus y is this one, that is minus k1 plus 4 by 3 k2 plus 2k1 minus 3k2. So here we will get k1 then minus 5 by 3 k2. So x is equal to my k1 minus 5 by 3 k2, y equal to k1 minus 4 by 3 k2, and z equal to k1 and w equal to k2. So this is the solution of these equations. Let us go for another example. Find b such that the system of homogeneous equations 2x plus y plus 2z equal to 0, x plus y plus 3z equal to 0, 4x plus 3y plus bz equal to 0 has first condition is trivial solution, second condition is non-trivial solution. So here we have to find the value of b. So first of all, we have to write the matrix A. So matrix A is equal to 2, 1, 2, 1, 1, 3, then 4, 3, B. So this is matrix A. Then how will we find B for these two conditions? So for the trivial solution, we have determinant of A not equal to 0, and for non-trivial solution determinant of A is equal to 0. So here we have to find the determinant of A. So determinant of A is equal to, here we will get 2 into 1 into B minus 9, then minus 1 into B minus 12, then plus 2 into 3 minus 4, and that is equal to, here we will get 2b minus 18, then minus b plus 12, then minus 2, and that is equal to b minus 8. So here determinant of A is equal to b minus 8. And for trivial solution, this determinant is not equal to 0, that is b minus 8 is not equal to 0. That means b is not equal to 8. So here b is not equal to 8 for trivial solution, and for non-trivial solution, for non-trivial solution Determinant of A is equal to 0. That is B minus 8 is equal to 0. That is B is equal to 8 for
non-trivial solution.
So in this way we are finding the solution of system of homogeneous equations. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.